Hi everybody. Sorry I'm not here on our first day of our new semester. I'm in Lansing at a track coaches clinic, but I'm looking forward to seeing you guys on Monday. Hopefully you enjoyed your snow days. Today we're going to jump into chapter 8 in our book, which is exponents and exponential functions. So first semester we looked exclusively at linear functions, okay, straight lines. Now we're going to start to look at different kinds of functions. We're going to do exponents, we're going to do these things called quadratics. But today we're jumping in just exponents, which you guys are familiar with. We did a little bit in chapter 1. Okay? So we're going to do some quick notes, and then I'll let you guys work on homework. So powers, just in general, okay, are expressions that represent repeated multiplication. Okay. So for example, when we say x to the power 2 or x squared, we mean we're multiplying x by its times. Okay. If we remember, we broke up our exponent into two pieces. We've got our base, which is our exponent, which is the 2. Okay. So if I ask, what's the base, what's the exponent? The base is what we're multiplying by itself, and the exponent is how many times. Okay. Now, what we're going to start to look at today is what happens when I start to multiply and divide and do different things with these exponents. Okay, so I'm going to color code this a little bit. So first thing we want to look at is, well, what happens when I multiply two exponents or two powers with the same base? Okay, and that part's important. Okay, well, x squared, okay, well, that's like x times x. And if I'm going to multiply that by, let's say, this x cubed, well, the x cubed is x times x times x. Okay, so all total, when I multiply that all together, well, I've got 1, 2, 3, 4, 5 x's. Okay, so my final answer looks like x to the power 5. Okay, so if we notice what happens here, well, we took x squared and we multiplied by x cubed, we said our answer should be x to the 5th. And well, hopefully we notice if we look at our powers, okay, well, what happened here? Well, we did 2 plus 3 equals 5. Okay, so this is kind of our general rule that we see down here. So when we multiply powers that have the same base, we add the exponents. Okay, but again, this only works when they have the same base. Okay, so make sure we check that first. So the algebra for this, okay, if I've got x to some power a times x to the b, well, that's x to the a plus b. So I'm multiplying with the same base, so I add my exponents. Okay, and as an example here, if we did x to the 7th times x to the 4th, okay, well, I would add my exponents, so this would be x to the 11th. Okay. So let's go ahead and do some examples. So 2 squared times 2 cubed, well, I've got the same base. And I'm multiplying, so I'm going to do 2 plus 3, gives me 2 to the 5th. Okay. For b, well, now I've got 3 things, but same idea. We're just going to go ahead and add all our exponents since all of these are being multiplied and they all have the same base. So 9 plus 3 is 12, plus 4 is 16. So this part should be w to the 16th. C starts to look a little different. We've got negative bases here. Doesn't matter. Same idea. I'm still going to leave negative 6 as my base and add my exponents. 2 plus 3 is 5. Okay. Just as a quick side note, okay, remember that these two things are different. Okay, so these are not the same. Okay, this top one is like -1 times 6 times 6, and so on. The bottom one says I should do -6 times -6, like that. Okay, so if you want the negative to be part of your base, it needs to be inside the exponent. So be careful with that. The last one can be just a little bit tricky. Okay. 8 to the 4th times 8. Well, if you don't see the exponent here, there's like a hidden 1 exponent, right? I'm just multiplying 8 by itself 1 time. Okay, well, now this is easy. I've got the same base. I'm just going to add my exponents. So this is 8 to the 5th. Okay. So that is our product of powers property. And hopefully you're feeling okay about that. Okay. I'm going to go ahead and I'm going to scroll down here.